Show that the two triangles in question 11b are congruent by completing the flow chart. So this is definitely an abbreviated flow chart proof. It's not what I would consider. Well, it's pretty complete. I'm going to grab this diagram from up above and just bring a copy of it down here so that we can refer to it here. So it's really important that you can see. You need to be able to see the diagram you're dealing with when you're doing a flowchart proof. So I'm trying to establish that triangle MIT is congruent to triangle NIT. So I'm going to draw that. I'm going to write that in here first. So triangle MIT is congruent to triangle NIT. Whoops. Let me get triangle NIT. And when I gave the triangle congruence condition above earlier, I said the reason was hypotenuse leg. So let's see if we can support that up above, right? So this needs certain things to be true. And certainly one of the things that needs to be true is that I have to have right triangles. Now, this is pretty much just asserted here, right? Triangle MIT and triangle TIN are right triangles, and that's got absolutely no bearing on the order of the corresponding parts, but it doesn't matter. They're right triangles, right? They both are triangles that contain right angles. Although probably it'd be nice to have the order the same so that you could kind of infer maybe if you knew the hypotenuse of one, the hypotenuse of other. But they're right triangles. Now, in order for them to be right triangles, they need to both contain right angles. And certainly it's clear that one of them does, right? If I look at the diagram, I can see that one of them has a right angle. And for the purposes of this proof, you can just say, look, they're right triangles because it's given. In actuality, there's probably a little bit more nuance to this, right? For certainly these two angles, I could say angle 1 and 2 they form a linear pair. So I'm basically inferring from the diagram that those two angles add up to 180. They form a linear pair. One of the angles in the linear pair is 90 degrees. And if I take the linear pair 180 and subtract 90, I get that this has to be 90 also. This has to be 90 degrees also. And if it has to be 90 degrees, then this has to be a right angle as well. So certainly at some point in my mathematical experience, I probably would have put more steps in than just this. But I'm okay with you looking at this and inferring from the diagram, yeah, for those reasons, they are right triangles. The other thing that has to be true is I need a pair of congruent hypotenuse. Their hypotenuses have to be congruent, and I can see from this diagram that they do have H congruent, right? They both have hypotenuses that are congruent. And you can see the hypotenuses are, for example, TM and TN. Those are hypotenuse, and it's given that they're congruent. So I could simply just say this, that I'll say MT, segment MT is congruent to segment, I guess do NT. Segment MT is congruent to segment NT. And that is given, right? There were tick marks on those lines. And what that's providing me is the H in HL, right? I now have congruent hypotenuses. So that's one of the conditions that I needed. The other thing I need is a pair of congruent legs. And when I look at this diagram, there aren't any of the legs that are marked congruent, right? There are two pairs of legs that we have, right? We have this, this is a leg, and it goes with this leg over here. And then I also have this leg, and it turns out that it's the same in both sides, right? Both of those triangles share segment TI. So I can say, hey, because they both contain the segment TI, right, it's congruent to itself by the reflexive property. So certainly it's not given that they're congruent because there's not a line on there marking it as congruent to something else. But because of the reflexive property, we can certainly say that TI is congruent to TI. So we'll say that segment TI is congruent to segment TI. And that is because of the reflexive property. So generally, if you see tick marks or things in the diagram that indicate segments are congruent or angles are congruent, you could just say that they're congruent and that's given. That's what's happening here. And in a way, kind of that's what I'm doing here with the triangles, right? One of those triangles had a right angle in it, so there's an extra step of saying therefore the other triangle has to have a right angle as well, but kind of like this is like it's close to being given. But for now, it's fine. We'll just refer to this as given. This, however, is not given, right? I don't have a markings on it showing that TI was congruent to itself. So that's why I'm using this thing called the reflexive property, right? Any angle or line segment is congruent to itself. And since TI is in both of those triangles, right, I can say, hey, TI is congruent to TI, and that's the leg that I needed. So this is our completed proof. All the parts are there. We've got our congruent hypotenuse, congruent legs, and they're definitely right triangles. So these two triangles are congruent by HL.